What if I told you the future of evolution isn't biological, but quantum? What if the next step in human advancement depends not on natural selection, but on qubits? Welcome to Hexagon, the place where science fiction turns to science fact. Today we're diving into one of the boldest questions of our time. Can quantum computing change the very nature of evolution? Biological, digital, and beyond. Let's start with the basics. Traditional computers use bits, ones and zeros, to process data. This binary logic has powered everything from smartphones to space missions. Quantum computers, on the other hand, use qubits. Qubits can exist in multiple states at once, thanks to superposition, and can become entangled, meaning a change to one instantly affects another, even across space and time. This gives quantum computers the power to process unimaginable amounts of data simultaneously. Instead of trying one solution at a time, quantum machines can explore many possible outcomes all at once. It's like calculating every alternate reality, in real time, with near infinite parallelism. But what does this have to do with evolution? Evolution is nature's most powerful algorithm. DNA mutates, environments select, and the fittest survive and reproduce. Over millions of years, this simple process has created everything from bacteria to blue whales, and us. But evolution is slow. It's blind, random, and takes millennia to refine even the smallest trait. It's nature's trial and error method, running on the clock of deep time. But what if we could speed it up? What if we could simulate evolution, billions of years of it, in a matter of days, or even seconds? That's where quantum computing comes in. Quantum algorithms could model entire ecosystems, genomes, or organisms in hyper-detailed parallel simulations. Instead of testing mutations one by one, quantum systems could evaluate all possible variations at once. It's not just accelerated evolution, it's directed evolution, guided by intelligence, not randomness. Imagine combining this with CRISPR, the gene editing tool. We could run millions of quantum simulations to test exactly which genes to edit, not just to cure diseases, but to enhance strength, intelligence, resilience, even longevity. We'd no longer wait for evolution to act. We'd become evolution's designers, curating humanity's next form. Want humans who can breathe at high altitudes, grow crops on Mars, resist radiation or extreme temperatures? Quantum evolution could engineer those traits before we ever step off Earth. But this power isn't limited to biology. Let's talk about artificial evolution. Right now, artificial intelligence learns through training data sets and trial and error. Still limited by classical computing, bottlenecked by hardware and time, quantum artificial intelligence changes the game. Imagine digital organisms evolving inside a quantum simulation, mutating, adapting, and reproducing faster than anything organic ever could. These wouldn't be static programs. They'd be living algorithms, digital species evolving in environments we design, self-improving in real time, beyond our control, beyond our imagination. Some might solve problems, some might create art, some might even develop consciousness, or something like it. And just like in nature, we won't always know which traits will emerge. Some of these digital life forms could outpace human intelligence. Some might even evolve new motivations, goals we never predicted or prepared for. This leads us to a question no one can fully answer yet. What happens when artificial evolution surpasses biological evolution? Do we become obsolete, or do we merge with our creations, forming something entirely new? The convergence of biology, technology, and quantum computing is setting the stage for something profound. Not just a new species, but a new era of life. We're standing on the edge of a post-Darwinian world. In this world, evolution becomes a tool. We stop evolving by accident and start evolving by intention. The implications are massive. Who decides what the ideal human looks like? What happens when countries start racing to evolve better soldiers, smarter citizens, or genetically optimized leaders? Will access to quantum-enhanced evolution be equal or reserved for the elite? And what about ethics? If we simulate conscious beings in a quantum computer, do they have rights? What if one of those beings asks us to stop the simulation or begs not to be deleted? Quantum evolution could unlock godlike power, but also unbearable responsibility. Still, the potential is too great to ignore. Imagine eradicating all genetic disease, designing climate-proof crops, creating artificial minds that can solve problems we can't even comprehend, or extending human life far beyond its current limits, perhaps centuries or more. In this future, we might not just simulate evolution, we might simulate entire civilizations, testing social models, evolutionary pathways, and planetary ecosystems before implementing them in the real world. It's a future where evolution is not just biological, it's not even artificial, it's programmable. A future where life is code, and we are the coders. From deep learning to deep life, from Darwin to design, this is where quantum computing takes us. But with every leap forward, there's a risk. Unchecked power, digital life forms we can't control, genetic experiments that go too far, or a species, ours, that forgets what it means to be human in the process. So the question is no longer whether we can direct evolution, it's whether we should. And if we do, how do we make sure we evolve wisely? The answer lies in how we balance power with purpose, speed with soul, and code with conscience. We stand at the dawn of a new age, not just of technology, but of transformation. Evolution shaped us. Now we may shape it. This is no longer science fiction. This is science future. The future of life is quantum. Thanks for watching. If this made your neurons fire or your soul question reality, give this video a like, hit subscribe, and comment below. Do you believe quantum computing will guide our next evolutionary leap? Or will it open a door we were never meant to touch? We'll see.